every component. There's going to be it's always going to have resistance, it's always going to have total, it's going to have current, and it's probably most likely going to have some kind of power. So there's always four things that we can always find out about any one component or device. So Watt law just states that my power is equal to my current times my voltage. That's how we calculate out power. Now, with these two formulas, that pie chart that I just handed out, or that's on page 103, that big pie chart is derived from only these two formulas right here. So, for example, let's say I wanted to find out power, but I don't know my voltage, but I do know my current and my resistance. So what I can do is I can substitute that formula. So P is equal to, typically is equal to IE. And I can go ahead and I can substitute IE. And so what was another name when I said a voltage drop? What's another name for a voltage drop?
Electromotive force.
Electromotive force. And what's another name for it?
IR drop.
IR drop. Okay? Because I times R equals my voltage, right? So if I know my current and my voltage, I can just go ahead and cross this out and substitute it for IR. So then what my formula turns out to be is I times R equals my power. And if I want to reduce that down, it would be what with the I squared R is equal to my power. So any one of these formulas that's on that 103 or the one that got handed out are derived from only these two formulas. And we can go ahead and substitute any one of them and get the other ones in there. So for here example, we substituted our voltage with IR, and then we reduced it down to I squared R. So P equals I squared R. And if you look on your page 103 there, you'll see that that's one of the power formulas is I squared R. This is one I use quite a bit there too. Alright, so let's take a look and start analyzing this one, this time with power. And then, let's do that. Let's first analyze this and then we'll talk about the power here. Alright, so what's the first step I want to do? Yeah, draw my electron current path. It's going to come down, put my polarities across each one of my components, so as it goes through, this is always going to be more negative than this side. Go through the switch, it's going to be more negative than this side. Do my current meter, more negative, positive, more negative, positive. Yeah. Alright, then what's my next step? Fill in what I know. What do I know about this one?
Yeah, 100 volts total.
Got 100 volts total.
Yeah, 100 milliamps.
Got 100 milliamps. We're going to put that 100 milliamps.
I1.
I1.
And
on the current total. My current remains constant in the series circuit, so I know that I have to have 100 milliamps here. Okay? Okay, so now we can go ahead, so now we know two things, so once you find out two things, then we can find the third and the fourth. So to figure out my resistance, I have to do what? How do I calculate it out?
B divided by I.
Right, so B divided by I, so if I cover up R, I take my voltage divided by my current, and I'll get my resistance. And what's my resistance total? 1 kilo ohm. And that's, make sure we get our 4 digits. Okay?
It's also good to figure out your power.
Hey, we can figure out the power. Might as well figure out that too. We might as well figure out our power. And what would I use for calculate out my power?
I squared R.
Yeah, I squared R would work. Or I times E would work. Yep, so either one of those would work. Yeah, so either one of those equal power. All depends on what you have for information. So if you use a simple formula, if you just remember that Watt's law spells out pi. PIE. So, if you're trying to think of how to calculate out power somewhere, years down the road after you're out of school, and all of a sudden somebody comes up and says, how do I calculate out power? Just remember that it spells all pi, so then you know that P equals I times E. Alright, so then what do I get for power then? 10 watts. Okay, you want to agree with that?
Yes.
Alright. That was my next step. Well, we know that we have a total resistance of 1 kilo ohm, and we only have one resistor. What's our 1 going to equal? 1 kilo ohm. How to do the color code for it, and what's the color code for it? What is it? Brown, red?
Brown, black.
Brown, black.
Oh, brown. Yeah, you're right.
Brown, black, red.
Brown, black, red. Yeah. Black is 0, so it's brown 1, 0, and then 2 more zeros, 1, 2. Yep, so brown, black, red, and then we know it's gold. Alright. Okay, then what can I figure out? My voltage. I can calculate out my voltage, and my voltage is just going to be what? Calculate out voltage, I can calculate it out. I times R, it's my IR drop. So my voltage is what? What is it? 100 volts. Same as my source voltage since I only have one resistor. How about my power? 10 watts. It's the only resistor, it's the only item on here that's giving out any power. This is the total power of the circuit, but that is 10 watts is being generated by this resistor. So on our, turn to the page here. So on page 85, and on your little study guide there, we ask, what is power? Power is the rate at which energy is used. Remember, everything we do in this class is typically based off of time. We can have a lot of energy, which is in joules, but until we actually do some work with it over a certain amount of time, it becomes power. So we're always dealing with power. Some type of work that's being done over a certain amount of time. And they show that on on there, 1 watt is the amount of power, 1 watt is the amount of power when 1 joule of energy is used in 1 second. So it's based off of a time. But to calculate all our power, all we need to know is this pi formula right here. So power can be anything that's, for example, let's say this was a resistor. This resistor is going to generate a certain amount of heat. Okay? That's our power. We can have a light bulb in there. The light bulb would have resistance. It's going to shine, it's going to light up, and a light bulb is going to give us both light and heat energy. And that's going to have a certain amount of power. So, for example, if I put in a 60-watt light bulb into my light socket, I'm going to get 60 watts of power with a combination of both heat and light. Now, all of a sudden, I put in a 100-watt light bulb in there, I'm going to get more heat and more light because I'm using more power. Okay? So it's our power, it's the rate of energy being used over time. And we're really going to be talking about power, especially when we get into AC, it gets to be a big factor. And our labs is going to kind of show us some things about power that are going to be really important to us when we get into AC. For example, when we talk about power, if we ever talk about like the radio station you listen to or something, you know, might say that it's 1,500 watts of power, you know. That's an electromagnetic field. That's a type of an energy that to broadcast that out, we have to have a certain amount of electromagnetic energy coming out of our radio antenna. That's our power.
That's a little broadcasting.
Yeah, that's what I can see that out.
At 50,000.
Yeah, like I think a WCCO or something like that, 50,000. So then what we're going to get into is and we're going to kind of see it in our lab. They're not going to really tell you what they're doing, but it's going to be important for us down the road and stuff. Is what we call our half power. It's our power curve. We want to know when do we get the maximum amount of power out of our antenna. And we call that our maximum power transfer. And so this stuff is all leading up to it. So even though they're not telling you in their labs what exactly it is right now, because it would be just way too much information all at once, it's going to lead into more stuff. So when you're looking at these labs, make sure you analyze your labs and kind of look at them and see what they're doing. You know, understand what that graph is showing when you graph it out.
So this is a radio?
It could be a radio, it could be anything. This could be just a heater, it could be anything.
Awesome.
Yeah, just but for a radio is a good example because that's where our maximum power transfer really comes in. Power is really important. Or if we're listening to our audio, you know, on the back of our radio, or on the back of our amplifier of our radio, you know, and you got your right and left jacks, and then it goes down to your speakers there, and it says. On there, you got some that say 4 ohms, some are 6 ohms, some are 8 ohms, some are, I think, are even getting down to 2 ohms if I'm not mistaken. We have all these different types of ohms. If you look on the back of your radio, it says what your radio is capable of, either 2, 4, 6, 8, or whatever, how many ohms. Well, if I have an 8 ohm system, I want to make sure I have an 8 ohm speaker. I'm going to get my maximum amount of power out of that speaker when it matches up with my amplifier. If I put in a 4 ohm, you'd think that I get more current, I get more power, but I don't. I lose my power. And we're going to see why when we get into AC for sure, but you're actually going to see that when we're doing our labs here this week. So you have to make sure that you match your impedance of your output with the impedance of that antenna tuner or your amplifier. And we're going to see that. It's going to be there, but it's just going to be hard to see, and you're not going to understand why. But we're just kind of looking at it in the back of our minds as we're just taking a look at that curve. And how's that power curve turning out? All right. Let's see. Yeah, so power is a big thing for us. We're talking about talking about audio equipment, you know, we're talking, 150 watts of power, or, whatever your type of devices are. So power is a big thing for us. We want to know how much power is out there. And then we want to make sure that we're matching our load, which would be my resistor here, or my antenna, or something like that, with my device. All right. So let's see. Let's do. All right. So do this one on your own here. The next one, 3-7. If you need help, have the guy next to you, ask him for help. Yeah, if you are, make sure you turn around, ask the guy behind you or the guy in front of you. Maybe I'll give the wrong answer. Yeah, I'm a lousy left-hander. You don't want me in.
What would you know about this stuff?
Yeah.
I know absolutely nothing.
Yeah. Alright. Do we have about enough time there? Alright, let's just take a quick look at it here. So I kind of go over our settings here. Alright. So what'd you get for resistance total? 1 milliohm?
Kilo.
1 kiloohm. Okay, and I do have bad hearing too, so, and I know it's the size of the lot, so. Or transpose the numbers, so I'll hear one number from you, and I'll probably write it all totally different, but. Alright, my voltage total we know is 20 volts. And my current total is what? 20 milliamps. And my power total is what? 400 milliwatts. Okay, R1 was what for value? 1 kilo. And my voltage? What is it? 20 volts. Okay, my current?
20 milliamps.
20 milliamps. And my power across my resistor?
400 milliwatts.
400 milliwatts. And my current meter are at 20 milliamps. Alright. So anything on this one here? Well, so hopefully everyone got the same answers. If not, find out why you didn't get the same answers as everyone else. Now there's another big concern. So if we're talking about a single resistor in there, and let's say my resistor value was 1 kilo ohm, and let's say that the wattage of it was 1/4 watt. Okay, that's the rating of that resistor. I'm looking over on page 91 where they have the ratings of the watt resistors. If it's 1/4 watt, would that resistor be okay to use in that circuit? No. Because 1/4 watt is actually equal to how many milliwatts? 250 milliwatts. So I have 150 extra milliwatts that's going to really heat up that resistor. So we have to make sure that we size up our resistors accordingly. And the only difference is that remember when I kind of handed it out, this resistor can have the same value as this resistor. This one just can handle more heat. It's got more surface area, and it can dissipate that heat a lot more. So we have to be careful about that. We got to make sure we size our resistor to the right thing. So we try to have to jump up to what size wattage resistor?
Half watt.
Half watt. It goes from 8, quarter, half, 1, 2, 5. So it jumps up. So yeah, you want to make sure that this thing was a half a watt. You don't want to go to a 1 watt because it's going to get a lot bigger. It's going to take up a lot more real estate on your board. Plus, they're going to be a little bit more expensive. So you want to kind of rate them appropriately. Now, if this thing was at, let's just say, for example, this one was at 500 milliwatts. This resistor would work for it, but it probably wouldn't be the best choice. You probably want it at that point. You'd be running so close to the borderline of it that if we want it for reliability, we probably want to jump that up to a 1 watt. Now, if we're selling it as a customer component, then we probably want to run it right at 500 milliwatts, so in about 5 years.
Thing
heats up and burns out and stuff like that.
Buy a new one.
Yeah. So, yeah.
Somebody had to pick a name.
All right. Okay, so any questions on any of those worksheets? I'll leave the rest of them for you to do on your own there and practice up on them and calculate them out. So tomorrow we'll go into lab. Now I know that we've kind of been dumping a lot on you here, so let's just kind of go over some of the things that need to be done here real quick. So assignment 1, you need to make sure that you get your lab signed off. You know what, Brad's got his lab 1 signed off, and maybe somebody else did. But you gotta make sure you get that. Make sure you get the lab demonstrated after the completion of the lab. So make sure you complete the lab. That one we had. Let's see, what do we have to turn in for that one? Is that a draft? That was our first draft, wasn't it? Yeah, so our first draft. And so we want that. We need to get that turned in. So before you get to, what I'm just going to do is just going to have so that we're going to get all back on track by next Friday. Okay, so. All the way up to chapter 3, everything's going to be due next Friday. All the way up to through chapter 3. Okay, so this is due next Friday. So if you don't get in time to get it plotted out, don't worry about it. Next time we go into the computer lab, we'll get them plotted out. We just have to make sure you have them done and on your flash drive so it's ready to be printed out. So this is due for next Friday. And I think that was the only assignment that we had on that one. That was just, that number 1, yeah, when we did the logarithmic graph and stuff like that. Okay? So you need to see that graph, and then you need to make sure that you have all your complete lab done. Make sure all your questions are answered, stuff like that. Show me that you have it, show me your graph, and I'll sign you off on it and get you checked off on that. Okay, number 2, the thing that we had was, let's see, we did this one, this is one that we did yesterday, right? Remember that lab 2? Come on, this week's now. So, lab 2 was the measurement one. That one you could do most of it that was at home, and then you just had to set up the power supply here. So that was the one how to do the basic measurements, reading the analog meters and stuff. So complete all the questions and just show me that you did it. You got it still hooked up and you can turn on the power supply and measure the voltage and stuff. So that was one was on lab 2. Then lab 3 was the measurements. And that's the one that we did further investigation for the 20 resistors, and we plotted that all out. So we just need to get that printed off, and you just have to show me that you completed your lab, and I'll probably have you demonstrate that you can show me how to measure a resistor. I'll come over with a resistor and you have to tell me what the value is. So I'll probably have you demonstrate your lab that way. Lab 4 then is our voltage measurement one. And I'm going to just make sure you definitely keep that circuit hooked up, because I'm going to have you show me that you know how to measure your circuit. I'm going to make sure that you got your right source coming out of your line jack and going into your circuit there. Now some of these other ones, like the application assignments, those are on the end of our chapter there. And they're also in our lab book, so it's part of our end of our chapter in our textbook, and then also typically on the last lab on that chapter. Those you can do those for extra credit. If you want to do those, you can turn those in for extra credit. Just remember though, all extra credit though, the only way you get credit for extra credit though is if you have all your other assignments complete. So you can't just also start doing extra credit because I give you so much credit for your extra credit stuff. You have to have all your other assignments completed before I give you credit for extra credit. So that takes care of that, and then now for this week here, these ones really actually go by pretty quick. It's more the graph that's really going to kind of throw you off. Then, so basically we got a couple of graphs that we're going to be doing. hooking up the circuits and just doing some tests and measurements. These are pretty quick labs if you just stay focused on them and get them done. So getting this all done by next Friday won't be any problem. Monday we'll start on test 4. So I'll just kind of wait for that. So I'm just going to quick go over. So here's our next lab that we'll start working on, our own lab. Again, try to do as much of it at home so that the only thing that you're doing is your lab work here. Don't be doing the questions and stuff here in class. Do those at home. But basically, I showed you that first chart. We're just showing you the linearity of voltage over current, the relationship between the two. So we just have to do some measurements, get some current readings. We're going to start hooking up a power supply. We have to know how to hook up a current meter. And be careful, you don't want to burn out the fuses in your MIDAC. Make sure you break the circuit and put your current meter in where the break is at. So I'll be watching for that. I'll be looking at that. I'll have you hook up your current meter on this one to demonstrate it. I want to make sure that you have your clarity of your amp meter going in there okay. And again, we're going to do it with 3 different resistors. So really on this graph here, when you're getting it graphed out, you're going to get 3 different. You're going to have 3 different series. Okay, so R1, R2, and R3. And you're graphing those out. Remember, those are our series. And it tells you that plot the current on. So this one's going to be our current and our voltage. So this is going to be your X values, and this is your current is going to be your Y values. And then you remember how to do your series. So that's a very basic plot that you can do. So you can have 3 different resistors all on the same plot. You have to take the data from that one, plot it, take the data from number 2, plot it, take the data from number 3, plot it, and put it all in one plot. Alright, then there's some questions that it's going to ask you. It's going to have you do some further investigations, and you do have this CDS cell in your parts kit. If you don't know what it looks like, look it up on the internet and see what a CDS cell looks like. See if you have one in your parts kit. Alright, number 6. This one here gets to be a little bit more complicated. And I don't want to really show you what the graphs look like, because I want you to kind of do that. So using the data, you're going to collect all your data and stuff. So it's going to graph the relationship of the power P2 as a function of resistance. So basically what they're just saying is that you're going to have your resistance is going to be here. And let's see, I got to make sure of X is plot the power and the Y value. So then your power is going to be here. So that's going to be, so this is going to be your power curve based off of P being your Y value, R being your X value, and your series is just going to be, it's just going to be like P2 or something, power P2. That's going to give you what your power is going to look like. Okay? Then the further investigation one gets a little bit more complicated. Well, we'll go over this one. I can kind of help you out when you get into the lab there. Because this one here is further investigation. But try to read it and see if you can understand what they're asking for. So once you plot that, so on this one here, you're going to actually have, this is all going to be done on one plot. So you're going to have 4 different series on that one. All right, so we'll be in lab. Make sure you bring your MIDAC tomorrow. And let's get some of these labs checked off.